So now we're using Cramer's rule with systems of equations that are either consistent and dependent, which means they have infinitely many solutions, or inconsistent and have no solution. And how we determine that, if, this is how I always like to remember it, if d sub x over d, well, we'll go ahead and just use equals dy over d equals dz over d, which equals 0 over 0. In other words, if every single one of the dependents, or every single one of the determinants is evaluated to 0, then that means that there are infinitely many solutions. However, if any, so if d equals 0, but dx, dy, or, that's the key, or dz do not equal 0, and that means there's no solution. So let's look at the given system of equations. We have 4x minus 3y equals 8, 8x minus 6y equals 14. I've written down the determinant using the coefficients 4, negative 3, 8, negative 6. So that equals 4 times negative 6 minus 8 times negative 3, which equals negative 24 plus 24, which equals 0. D sub x, we replace the first column, the x coefficients, with the constants. So 8, 14, negative 3, negative 6. That equals 8 times negative 6 minus 14 times negative 3, which equals negative 48 plus 42. So that equals negative 6. So we don't even need to, we'll go ahead and look at dy. And that's going to be 4, 8, 8, 14. And if we evaluate that determinant, we're going to have 4 times 14 minus 8 times 8, which equals 56 minus 64, which equals negative 8. And as you can see, d equals 0, but d sub x and d sub y both equal something that is not 0. So that's this second situation up here. The determinant for the coefficients equals 0, but each one of the variable determinants does not equal 0, and that means that there is no solution to the system of equations. Now again, remember, if we ended up with this first case scenario, if all of the determinants equal 0, then there are infinitely many solutions, and we could solve for in terms of one of the variables, just as we have in the past when there are infinitely many solutions. We can define it a little bit better than just infinitely many solutions. We can determine the specific nature of those infinitely many solutions. But in this case, both of the coefficient, or both of the variable determinants were values other than 0, and the determinant for the coefficients was 0, and therefore there is no solution to the system of equations.